Hi, welcome to our project presentation, Network Protocol Efficiency Analyzer. Before getting to it, I will introduce myself. I am Mufsala Tamrit, wireless telecommunications student. This is an industrial project sponsored by PLC Group. Network Protocol Efficiency Analyzer is a project designed to access and optimize Modbus and SNMP protocols. These protocols are essential for communication in industry automation and network management. It focuses on CPU utilization, memory usage, and response times. It simulates real-world network conditions for thorough evaluation, and it helps identify areas for improvement and optimize network management systems, and it ensures reliable and efficient communication in interconnected systems, enhances system performance. The primary objective of this project is measure and analyze the performance metrics such as CPU utilization, memory usage, response time, and network traffic. As a part of project, we have developed sophisticated algorithms and we have used tools like Zabbix and Modbus simulator software to simulate real-world network conditions. Our project underscores the importance of network monitoring in maintaining optimal performance and preventing issues in both industrial and IT environments. We have used two protocols. First one is Modbus protocol. It's an industry standard protocol developed in 1917 by Modicon, and it follows a client server architecture where on one device client device is initiate communication with the one or more devices server devices. It enables communication between industrial electronic devices over various networks. Another protocol we have used is SNMP protocol. It's a main protocol for network management and monitoring. It operates on a agent manager model. The SNMP manager communicates with the SNMP agent to get or retrieve information on a network device. The other portions will discussed by the other teammates, Kajal and John.
Hello, John Olawi here. I'm a team member for the Network Efficiency Protocol Efficiency Analyzer project. So I'll be taking you through slides explaining our project architecture, the tools and technologies deployed, implementation process for the Modbus on the virtual machine, and also the implementation process on the test device. That's the device under test. Here is a slide for our project architecture. You'll see from the architecture, you can see how our device under test is integrated with the SNMP device and then the Modbus devices. The device under test, well, we're referring from now from the DHC, was running on a Windows server with the Modbus simulator on it. So while our Modbus clients, we have a Modbus client virtual machines, device one, device two, device three. Majorly, we have multiple Modbus devices just to stress test the system and to push it to the maximum limit. There are our SNMP devices, just one. So we are making use of Zabbix. It's running on Ubuntu, and we have Zabbix running on it. So this monitors the network traffic and the performance metrics we need in this project. So our tools and technologies used, as explained, is the Modbus simulator, and we have the Python running on the Modbus devices, and where Zabbix is also running on the SNMP device. So the Modbus simulator on the DUT, the Python program running on the Modbus devices, and Zabbix running on our SNMP device. So for the Modbus simulator, it just simulates Modbus devices, testing and validating it, and also all the configurable processes and the conditions that needs to be met while testing the devices. So, and the Python program running on our Modbus devices, you notice if I go back to this slide one, We have the Python running on Modbus 1, Modbus device 1, Modbus device 2, and Modbus device 3. So we have Python running on those programs. So we're utilizing Modbus library for the Modbus communication throughout the Python program. So the Zabbix is one providing us with SNMP monitoring and alert capabilities, and also the customizable dashboards for the data, which we are going to be showing you later on. So the implementation on the Modbus devices that we configure the Modbus virtual machine on Windows, that you remember I told you the Modbus is running on a Windows virtual machine. So we have Modbus 1, Modbus 2, Modbus 3. So we installed Python on them, and for the Python to run, we installed Visual Studio Code, and the Visual Studio Code was running on the PyModbus, which is the Python library that's needed to run Modbus. So we wrote the executable program and the scripts which keeps on pinging and sending these Modbus pings to the device under test. So for the implementation of the DUT, that's the device under test, you have the Modbus simulator on that device. So it is configured on Windows. It's running Windows Server actually. So after running Windows Server, we activated the SNMP services, and we installed up the requisites required for SNMP for the SNMP services. Then before the Modbus simulator was downloaded also, remember the DUT is having both the Modbus and the SNMP services running on them. So SNMP from Zabbix coming from the SNMP device coming to the DUT. So the DUT is actually in two phases. DUT as an SNMP services, and DUT as the other phase is actually the the Modbus simulator. So the DUT has SNMP services running and the Modbus simulator. So from this diagram, you'll be able to see that our DUT running on Windows, SNMP services activated, and also installed all the requisites for the SNMP services. Then the Modbus simulator is downloaded and installed.
Hi, I'm Kajal Michael. First, I'm going to explain about the implementation process for SNMP. Uh, we done the SNMP actually in Ubuntu virtual machine. First, we set up the virtual machine in Ubuntu and then install the SNMP tools on SNMP virtual machine. And we set up the Zabbix on SNMP virtual machine. We actually use these Zabbix in order to get the data of the device under test, like the CPU usage, memory usage, and other performance metrics. Then we configure the Zabbix database in order to collect all the data of the device under test, and then configure the Zabbix server, and we access the Zabbix UI, and then we configure the host in the Zabbix. All the details of the host is the detail of the device under test. And next, we usually take three test cases. The first one is to scan for the Modbus TCP devices, and in that we ensure the scanner can locate and interact with the Modbus TCP device over the Ethernet. And then the second test case was the SNMP monitoring. We verified the ability to monitor the SNMP devices, and we retrieve the performance metrics using the Zabbix dashboard. We can see all the performance metrics through different graphs and data. And the third test case was the performance measurement. We evaluate the network protocol efficiency and analysis accuracy in measuring the CPU utilization, memory usage, and then the response time. These are the result we get from the Zabbix server. The first graph will show the this graph will show the CPU utilization of the device under test. The peak shows that the time at which all the Modbus client send the ping request to the device under test. So this peak will show that time. So the CPU utilization at that time was so high compared to other event, and this one is the ICMP response time of the device under test. And this graph will show the network traffic which go through the device under test. And this one is the space utilization. The blue part is the total space available in the device under test, and this red portion is the space which is actually utilized. And this is the explanation of all the chart and graph. The first one, network traffic graph, show the network traffic over time for Modbus and SNMP devices. The spike, I already mentioned that the spike indicate the high network activity period, allowing identification of potential performance issue. And then we can get the bit sent and received. It actually displays the amount of data sent and received over the network, and it shows that steady flow with occasional peak, usually for accessing data transmission efficiency. And the next one is ICMP response time. It shows the response time for ICMP ping request, and consistent response time with minor variation, indicating the stable network performance. And the next result was the CPU utilization. We monitor CPU usage on the device under test, and the peak usage period highlight the load on the CPU, useful for optimization. And the last one is memory usage. It's track memory usage over time. Consistent usage with minor peak, indicating the efficient memory management. These are the result and analysis. The functionality of the network protocol efficiently measured and reported the performance metrics. We show that through the graph on the SABIC's dashboard, and the reliability which demonstrated robustness handling various conditions without failure. And the last one is the usability, which show that the user-friendly interface facilitated easy setup management and data interpretation. And these are the main conclusion we have got through this project. The first one is the network protocol efficiency analyzer will provide a comprehensive tool for evaluating and optimizing both Modbus and the SNMP protocol. And we also successfully developed a solution that measured key performance metrics and offers insight for optimization. I shown that through the different graph on the SABIC's dashboard. And the next one is we identify the performance bottleneck and areas for improvement. Then utilize advanced monitoring tool like SABICS for real-time data collection. And also we highlight the importance of continuous monitoring and optimization in network management. And last, enhanced overall performance and reliability of the network system. And the future scope of this project include we can integrate with IoT platform for the seamless data collection and analysis, and also mobile application can be used for enhanced usability and accessibility. And also we can use this for automated discovery and configuration of Modbus and SNMP device. Here we done it all through the manual configuration. We can make it automated, and then advanced analytics and machine learning for deeper insight and optimization can be used in future. And also we can create this network protocol efficiency analyzer by adding additional protocol like BACnet, TNP3, MQTT, and etc. And thank you. That's our project overall, and thank you so much for watching.